Guys, starting in 2 minutes.
Hello everyone, am I audible?
Yeah, you're audible.
Hi. Yeah, so let me know when can we start?
Yes, sir. All join. Now you can start. I'm
Okay.
giving this access. Okay.
Okay, fine. Thank you. Just a minute. Just give me a minute. Yeah, am I audible? Hello. Am I audible?
Yes.
Okay, fine. Okay, fine. So we'll start now. Okay. So just want to understand, we covered something in the last session. So are there any new people here in this? So that I just start like whatever I discussed, I will also cover that in like briefly, and then probably we can go to the next stage. So let me know, like, there are any new people who did not join the last session.
Hi, it's Sandesh here. So this is starting from today itself, right? Or because I'm joined today is the first session I joined. So
Yeah, so it start like we covered only basics of DevOps in the previous session. So it was kind of introductory session, so which we can obviously cover from today. Like we will just go through that as well.
okay, no problem.
So
Yeah.
my expectation was that all people are like people who joined the last class. Yeah, but since you are new, I think we can also.
Yeah, sure.
Sure. Yeah. So sorry, your name is you mentioned Sandesh, right?
Yes,
Yeah.
Sandesh.
Sandesh, can you just give me a brief introduction about you, because so that like we are in sync and I understand what are your requirements.
Sure.
Yeah.
So I'm a network engineer currently, and working with the Cisco systems, and having experience of around 10 years. So the thing
Okay.
is just means currently the as the word is turning towards the automation side, and I don't have the experience on that thing. So that's why I want to learn on that things like the CI/CD pipeline, Jenkins, and the DevOps stuffs. So that was the thing.
Any prior experience you have, like anything from this stack, DevOps stack?
No. So this is the first time actually. So basically, the roadmap for this one is we are covering automation tools and a CI/CD pipeline, Jenkins, and
Exactly. Yeah, exactly. That's what we are going to cover here. So I think you have been already explained about the course duration could be 3 to 4 months. Okay. And so every Saturday, Sunday, we would be having classes. Okay.
Yeah, and one more thing. So does it require the coding thing to be
No.
exercised?
It is very misconception to the people that DevOps includes the coding. See, DevOps would require knowledge of Linux and somewhat scripting. Okay. So that you can automate the stuff, because like even if you will run the pipelines, right, you have to run some scripting commands, right, to do something like creating something. So that is what, but that can be learned. It is not like that you have to be expert to do it, because nowadays, right, you can write very simple codes even using there are ChatGPT and so many things, right? So you don't have to expert in coding. You need to just understand that what is your requirement, and based on that you can create a simple codes anyway, because when you are working in DevOps environment, there are developer teams actually working along with you. So DevOps team role is mostly to sit in between DevOps and operations team, or sometimes like they are engineer with different tools knowledge, because they are following this methodology. So it is more of they are working with development and operations team in between. Okay. So it is mostly like that. No coding experience anyway. See, because anyway, if we see industry going forward, I'm just going a bit off topic, but to let you know, now there are tools where you don't even require to write the code, right? So if you want to deploy something, there are power apps, right? No. So world is moving through no code applications. Okay. So even developers, I would say, like, you can, even if you don't have any development knowledge, using power apps and similar tools, right? I don't know if you know about power apps. This is Microsoft tool, and there are other tools as well in market. UiPath is there. So those tools you can use to create the tools without even entering single line of code. You have to just specify your requirements. This is what you require, and it would build the tool itself for you without any code. So that is the future. So just to give you, so in future probably you would see that developers would be more of where some expert, like very detailed or any very complex systems or applications need to be developed. But for any basic systems or basic applications, you would not need developers also. Okay, so that is the future where we are going. So don't worry about coding and all. It is more of we would be actually understanding these environment. Okay, so we'll just go. I'll just start sharing my screen.
Sure,
yeah, just a minute. Okay, so I hope you are able to see my screen.
Yes.
So we have all been working in the production environment, right? In different areas or in different ways. As I learned in the last session, that most of us are either network engineer or similar server administration team, right? So what I believe is that I would take it from that perspective, so that it is easy to understand, right? So how we have been doing development. So development for a network engineer would be configuring the routers, creating the configurations for the router, right? So it could be pre-post configuration where like you want to deploy thousands of routers on different sites, okay? And or you want to create like a virtual networks on the cloud, okay? Hundreds or thousands of virtual network on the cloud, and you want to deploy in the virtual networks, you want to deploy the security groups, network security groups, or virtual appliances in the virtual network, right? So all these, if like you would be in last 5 to 6 years, how would you do is that you will send one network engineer, field engineer to each site. Okay, he would carry the router, and what he would do is that he would have some very basic configuration where you would supply you will give one interface to be configured with IP address, a next hop, and a way to reach to the internet, right? And then or like he would have some tool like Terratom or similar tool, secure CRT, and he would give the access so that at least you have first access to the router remotely, and then you would have already created a post configuration where you would supply what would be the name of the router, what would be the different interfaces available, what would be the IP addresses on those interfaces, okay, and what routing protocol this router would be running, what routes, like you static routes it would be having, so all the and if there is any backend switch like any layer 3 switch, then what are the layer 3 interfaces would be there, DHCP configuration, all those things, right? You might all of you have done that. So this was all done manually. For one side, engineer will go and you would have to configure, right? Everything. So what if, but now what has come is that the devices has been very intelligent nowadays, right? So if you are deploying I don't know, like if you have a gone SD-WAN environment or not, but yeah, just to give you a perspective is that these devices can be pre-configured before delivering, okay, to the device. As soon as you will connect it on the remote network, those devices could be managed from, like, they would be plug and play, they would load the configuration automatically, right? So that is actually happening, which is which is kind of that there would be a consistent configuration template you would be following. So even if you are configuring 1,000 routers in the centralized system or on the cloud dashboard or whatever you call it, whatever is the vendor, right? They would have something as dashboard where you could load the templates of the 1,000 of routers, and as soon as the devices come online, boom, you have the configuration on all the routers, right? That's what we are moving. Okay. Now, but earlier, I'm talking about when we were not doing this automation stuff or this DevOps stuff, what were the pain areas? The main pain areas was that we were doing manual processes, right? Manual processes means first it starts from the purchasing the router, right? There we have to engage. So there were different teams engaged in this process. You would have pre-sales team, you would have architect team, you would have implementation team, right? In the initial stage, where they would be and obviously project management team who would be coordinating the project. So they would be discussing with all the stakeholders to understand that what would be the bandwidth for this. If they are designing for one specific site, they would, or data center. So first thing is that what would be the capacity? How many applications would be hosted? What kind of applications? If they are web servers, if they are SQL servers as well, right? Because the requirement is different. The traffic requirement is different. How much traffic would be reaching to this site? If it is a remote site, then you would see, okay, because it is remote site, hardly 100 to 200 users would be sitting here, and they would be generating the data. But if it is data center, it would be that all your customer, right? Like all your end users, whoever are working for your business, for them, they are replicating that every data on the data center. They would be loading the data, fetching the data. So based on how much the size of your company is, you would be building the capacity, right? The routers, the servers, everything you have to consider. So after detailed design discussions, then the project management team would engage pre-sales or sales team to like after a discussion what devices has been decided to be procured, and next stage like your team would negotiate with the vendors that we have this much order, so we need concession, everything. So and all these licenses, so everything was manual, right? And because everything was manual, it depended very much on the expertise of the architect team, the design team, and the sales team, right? As an implementation, like if you as a network engineer, you are an implementation guy, right? So all you have to rely is basically on the expertise of these guys who are working. So I'm not naming anyone, not a blame thing, but I'm just telling the system how it actually used to work. So so all we depend hello, am I audible?
Yes.
Am I audible? Hello.
Yes.
Give me a second, I think. Okay, fine. So all we needed the expertise from the design team and architect team. So if they did the job properly, they documented everything properly, right? So it would be easy for implementation or network engineer to implement it. What if that there was a requirement that the network engineer has to run the IPsec site to site, right? Connectivity from this remote site as a connectivity method. But later you learn that the license required for the IPsec. Guys, can you be on mute? There is a lot of noise is coming. Okay, perfect. So yeah, so you could see that we don't have the security license required for running the IPsec. That is a miss, right? Now I consider there are thousands of routers you have to configure, right? So again, it is back to the architect team. You would say if you would require IPsec configuration on this router, why the license thing was not considered? Now architect will say, oh, we missed it. So then architect team will engage with PM team, and they will engage with pre-sales, and they will again renegotiate with the vendor, saying that we need this license. Again, renegotiations on sale level. So there was a lot of flip-flop, right? You understand? So that was all the curse of manual processes. Second thing was ticket-based changes, right? So whatever changes you want to do, even a small change, even if like you want to add a VLAN in the trunk port of the switch, change window decided, and then you would be making those changes. So it was ticket-based changes which were very slow. Hard to build new environments, as I already explained, so I would not go further on this. Slow delivery, obviously, when everything you're doing manually, the delivery of the project would be slow, right? And also because there has been some inconsistencies in requirements gathering and all, so we might have to go back to the previous stage as well. So there was slow deliveries, inconsistent changes, inconsistent frequency. So it was inconsistent because, for example, you are having some change freeze happening in December, right? For everyone might have experience in network engineer, where you don't make the changes on the devices. There is a change freeze, right? So during that time, you would not see any work, right? Probably most of us would be scrolling through our LinkedIn or Insta, or like whatever. But there was very little work during this time, right? But as soon as the change freeze is lifted, you would be bombarded with so much work, right? So there would be so much changes happening, and there would be possibilities of the failure, because now earlier in the changes no sort of bridge releases in the pipeline, as I mentioned, with mistakes repeating. Now because there are I would say not hundreds, or like even in 10 route engineers are working, right? And they are building the configuration. So as engineer, we to enable these specific settings. We have seen that this have been failed in the past, right? As we some engineers will know, right? So this is causing inconsistent configuration. I have seen multiple times when engineers would go on the switch, and instead on Cisco router, instead of adding like a trunk VLAN, and what it would do is that while they wanted to add just specific VLAN in the like in under the port, uh, uh, it would just have that word VLAN, just because you miss that add part, right? So those were kind of repeating mistakes happening. Poor alerting. So poor alerting means when you will open your alerting tool, you would see a lot of alerts, right? So many alerts you would not even understand, right? So there's no proper segregation. It could be that the server is also alerting, and then your network engineer, you can see that, and then even for your device, there are so many alerts, you don't understand that which one I need to consider, right? There is an outage and you're getting so many alerts, and then it becomes so, it's like finding a needle in the haystack, right? So it becomes so difficult seeing those alertings, I would alert, right? So alert, it is very difficult, right? Now inconsistent hardening with mistakes repeating, that I already covered. And if there was what to say, if there was some deployment required, fast deployment required, management might pressurize, saying that if you we don't kindly open this specific port, we need this for our deployments, right? So it is a security compromise. I think someone posted a question. Okay, yeah. So Devinder, we would be, so what I'm planning is that I am creating a like a GitHub page for this training, so that I would post all these documents and whatever labs we would be doing here. I would update it on the GitHub document, and I would explain you how actually, because this is part of the DevOps, so we would be doing it in intelligent way. I would upload all the data on GitHub, and we would be explaining how to access GitHub, right? How can you access that data from GitHub? So yeah, so I will keep updating, don't worry. So we will reach there, and I will share all these things with you, right? Okay, this we have covered. Now what are the results of all the manual work we have been doing in the past years? Is that there was continuous fight between development and support team, right? So for as an implementation engineer, you got half-baked configuration or half-baked design, right? Now as implementation engineer, you did your job. Probably you might have a fight with your design team as well, that because you have hands-on experience configuring the sites, and you have while your design team is mostly on high level, right? I'm not saying that, but it is like mostly seen that the configuration team who is working, or the implementation team is working, they have more hands-on idea of the network than like what exactly the routing is running right now, how is the switching happening. They have more hands-on knowledge as compared to the design team who are actually creating a design, right? Because there are so many changes happening there every day, so they might not be in consistent update, like in the consistent loop of what changes has been done. So even if the implementation engineer implemented some design given by design team, and then there is then after what happens, the implementation is completed, then there is they would support it for 15 days and or 1 month based on like each company's processes, and then it would be the project would be given to the support teams for further support, like if there are any break fix and all, right? So what happens if the design is wrong, the implementation is wrong? What will happen with the product? It will keep breaking, right? Now who is suffering here? The support team is suffering. Why? Because it was done, the implementation or the design was done wrongly, and that is causing the problems. So then what would happen? There would be a continuous fight. The support team would say we were given a wrong implementation. They would blame network implementation team. Network implementation team will blame the design team, right? So there is continuous, and so we are all defending our positions. The support team is defending their position, implementation team is defending their position, and design team is defending their position, right? So what's happening? Instead of constructive work, we are fighting uh, over the failures, right? Always us versus them mentality. So we, as we do, right, we always blame the other side. Poor customer satisfaction, but who is suffering in this is all fight is the customer, right? And no one is bothering that it is customer who is suffering, right? So what will customer do if he's unsatisfied? He would find the options. It is a revenue decline for your company, right? No innovation, because everyone is busy in fighting. So obviously there is no scope of bringing new things. What will happen in all this chaos? The people who were performing, they will leave the company. What we are doing is knowledge waste, because we are not learning anything new. We are not learning from our mistakes. We are busy in fightings. Waiting waste, as I said, that because there are so many flip-flops, re-implementations, a lot of time is wasting and effort waste, because obviously we are doing the same production and everything repeatedly. What we are doing, we are wasting the manpower resources. Okay, any questions still here? I hope it's because this is like just from the experience you might have seen. So I think it should not be any something like where you would have queries, but this is just to let you know from where we are launching. Okay, so we are going next, right? Now, if we are forming a company, right? I think someone has posted query. Okay, so consider there is a company which is like you are forming, right? Like company name is DevOps. So what are all things you would see mostly in a company, right? This is just to let you know that how DevOps integrate with every aspect of the department, right? So there could be so many departments in a company, but from the IT perspective, we will focus here is that there would be a project management team. They are the guys who will understand the requirement of the project, right? They would list down all the nitty-gritties of the project, what are the different tools we will require and everything, and then they will work in close coordination with architecture team, right? So architecture team is something who would be basically like understanding the project requirements and will go in the detail like I would say design part of it, right? How the entire system, how much is the bandwidth capacity, how many users would be accessing these applications, what are the different security standards systems required, everything. So they would be building the blueprint of the company, right? Because they are architects, right? That is their job. They would be working in close association with business analysts. The business analysts are most of the people who would understand the gaps in the business, and they would work in close association with the project management team and architect team, or with customer directly to understand how can we further optimize their solutions and what new business avenues can be created. Then there would be quality assurance team who would ensure that the project delivery is basically as per the best quality. Then there is information security. Okay, information security team is mostly the team who are like will check all the ISO standards. Okay, who would make sure that the code is deployed or the configurations, router or whatever configurations are made as per the standards. There are no bugs in the software. There are no bugs in the configurations, right? And everything is secured and the environment is secured. And there are operations team. And operations teams are basically the ones who would be supporting suppose the project is deployed, they would be fixing the daily issues, right? And in the center stage is development. So development is the one who would be center stage because they would be touching each team, right? And that is why they are in between. Okay, so this is where mostly we would be sitting in between development and operations. Okay, and we would be, so as a DevOps we would be anchor and like be in contact with all these teams. Okay, next slide. Any questions? Okay, now DevOps cultural shift. So as name suggests, DevOps, Dev is formed of development and operations. So we would be kind of sitting in between, where we would be coordinating with DevOps. And I mentioned it is a cultural shift because, as I mentioned, there has been continuous fight in the past between developers and the IT operations team regarding the issues. Okay, now DevOps team is assisting both of them, right? So we'll talk. So what happens that it is a methodology where the development and operations teams are no further siloed. Okay, so we are merging kind of two teams in a single team. And so don't think that DevOps would be doing development. So it would be more of that we would be facilitating both operations and development. How we would be doing it is that a developer would come to us. I have these many line of codes. I want to push it to deployment. We will say, no, let's do this. Let's make these changes first in our testing environment. If this is successful, we will see it, test it entirely. We'll do the load test over it. And if everything is working fine in the test environment, then we will go into the production, right? So whom we are saving? We are saving the operations team as well here, because we want to ensure even if the development team has done the coding as per the design, okay, as per everything, we want to ensure that we want to replicate in the testing environment to make sure that when it goes into production, it does not have any bugs or any issues, right? So we are saving development team as well as operations team. So we are no longer siloed, right? So how we would work actually, generally DevOps team is some companies have a different team, okay, where there would be a DevOps department itself. Some companies you would have a different, like they would form a team, okay, and in that team there would be engineers from different backgrounds, right? So you would have the people working from the support, you would have people working from the development, and then you would have experience working on Jenkins pipelines, you would have experience working on GitHub, Git, right? You would have working experience on Azure and all deployment. So all of them, you are forming one team. And I said, like the major product companies, right? They would have mostly this kind of model where you would see like a single team which are having different people from skill set. So most of, like earlier it was like there is a network team just doing network job, right? So it won't happen like that in the product based company. So it could be Amazon, Microsoft, or any other company for say. You would have teams where there would be different people working from different skill set together in a single team reporting to the same manager. Okay, any questions? Okay. Okay, so DevOps is a set of practices, tools, and cultural philosophy. I mentioned, right, how it is a cultural philosophy because we are bridging the gap. We are removing the obstacles of the past, right? So we have to automate. integrate the processes between software development team and IT teams. Now, to implement any culture, right, we have to bring the practices and we have to use the tools. That is how we have to use the technology, whatever we want to achieve. So there was an earlier system, right? So there were some problems in that earlier system. Now we want to improve it. If we want to improve it, we have to create some rules because we want to operate in different way now. So we have to create those rules. Uh, Based on those rules, we have to build the tools, right? We have to understand what tools we can use to support our new system, right? So that is why DevOps is just not like a philosophy. It is not just a culture or tools. It is combination of all of them, right? So I'll just understand that. Now, what are the objectives? I covered in the last one is that because we are mostly the technical guys, right? So we would not go into, though I would cover somewhat like the different. I don't know whether you might have heard about that the methodologies, like there are Scrum, okay, Agile, waterfall model. I'll just give you a small summary, but that is more towards culture, right? How we are coming up with the culture, different cultures. But we are technical team, so our focus would not be more about like these models, like waterfall models, yeah, or like waterfall model, all these tools which we use, right? Our or agile method. Our objective would be more of the technical tools which we'll be using, right? But we will touch upon that also about the culture as well. Okay, so we would be able to set up production ready DevOps CI/CD pipelines. And now this is the keyword CI/CD pipeline. I would, for now, I will just explain the full form. CI means continuous integration. CD means continuous deployment and development. Okay, so we'll understand that in detail. But for now, just understand continuous means earlier we were having we would have to open a ticket. Okay, have to discuss with all the stakeholders. This is the change we are making, and then change window would be decided, and then we would make the changes. Now, what's happening is that we are obviously discussing about the changes, but now changes are happening every day. Okay, system is creating ticket already. Whatever changes we are making, we are not pushing the changes in one slot, right? So it's not like that if we want to configure say thousands of routers, right? We are doing simultaneously on the routers. No, first we are taking a snapshot of the configuration and we are creating a test environment, a environment which is similar to the production. Okay, could not be having that much of devices, but a broken down version of your production environment. Okay, where you could have, for example, you have kept one server and there is a front-end router for simulate that it could be a data centers, and then there are some applications you are running on the server, just to ensure that we want to ensure that it does not break anything, right? So this is a truncated down version of your production. Okay, so you pushing that code into testing environment, and it is happening all the time. Your testing team is testing everything continuously on test environment. If the results are good, you as a DevOps engineer or the developer will push the changes to the production. It has been tested now. Next change similarly. So as you can see, right, there are no ticket. Like obviously, when we are making these changes, there would be automatically this ticket would be created. You would not have to even worry, and the focus would not be on what is the ticket number and all. No, the focus would be on deployment mode. Okay, so it is. This is how we would see it. We would understand it. Any questions still here? Okay, so course benefits people who wants to shift from other technologies, right? So I have been also a network engineer, okay, in the past. So just to give you some perspective, I worked. Then I moved to somewhat a product team where I worked in close association with the developers team, right? So there I gained understanding of Jenkins, Okay, I got understanding of running the GitHub, right? How to push the pipelines, create the pipelines, all those stuff, right? And then I moved to cloud team where I learned more of mostly like the Azure. I got a good hands-on, like I would say I have good expertise in the Azure. Okay, and obviously while working all these things, I learned Linux. I would not say that I am expert in the Linux, but I know all these things which are required for developing like your scripts or basic scripts and running the commands, right? And it is not required for you to be a DevOps engineer that you should be expert either in Azure, AWS, in Linux, or in Jenkins. You would start it as a beginner in all these tools because there are a lot of tools, right? And then over the time when you will work on the production, you would also, you cannot probably would not learn everything, all the tools together, and that's okay because in your team there would be engineers. For example, you know about AWS or Azure, right? You have good hands-on, plus you know more about Linux, right? And then there would be a other person who would have expertise in Jenkins, and he would have expertise in working in monitoring like Nagios or Prometheus, and you together as a team, 2 people, or there could be 10 people, but 10 people, they would have some understanding working on Git and GitHub. Okay, and they would have expert level in some specific tool, and some basic understanding or some middle level understanding of, for example, Jenkins, or some understanding of Ansible, right? So this is how like a team would be formed, and then you will learn from each other. So it is a continuous journey, and this course, 3-4 month course, you will not become expert in DevOps. Even like after working, even if the course runs for 1 year, you will not become expert in all those things because these are different technologies which are having wider base. So if you want to become the Linux expert, you would have to give 5 to 10 years. Understand that way. If you want to become expert in the Linux, even like you guys might, whoever are having 8 to 10 years experience would not say that I am the expert network engineer, because network is huge, right? You cannot claim that I'm expert, right? You could have expertise in Cisco, or you could have expertise in Juniper, you could have expertise in other vendor, right? But you cannot claim that I'm expert in all the things, right? There is always a scope of learning. So this is how I want to make it very clear that any course is like, this course will give you enough understanding of the tools and technology that you would start to understand and try to play with yourself and gain more experience. Okay, based on that, the understanding, you can crack the interviews, but you have to keep practicing. Okay, any questions still here?
Oh yeah, one thing. So basically, the thing is, the initial start point is from learning about the Linux fundamentals kind of thing in this roadmap, or how it will be like.
Yeah, so just like my headphone, I think is broken. Just a minute. Am I audible?
Yes. Yeah.
Okay, am I fine? Yeah, now I think it's connected. Yeah. So see, we would be starting with Git, and so what was your question? Your question was about server.
No, so basically the learning path will go via the Linux fundamentals as well, like
Yes.
fundamental, then
See,
GitHub.
Linux fundamentals means, see, when we are running on Git, right? We are running the Git commands, right? Git is Linux. So whenever we would be creating the file, I would tell you, this, see how this is how we create the file. Right? And we would, when I would be moving the file or renaming the file, I will tell you, see, this is how we're renaming the file. If I want to see the size of the like what is the current utilization, I would tell you do it. if I want to change the read-write access of the file on Linux, I would tell that this is how we do it. It would that I would right, because Linux is a and it would have so many things. Okay, but yeah, we would be covering basics of what we require from the DevOps perspective. Any queries?
Oh, okay. Yeah, no problem.
Yeah. So as I said, we would be DevOps specific, right? So in Linux, you can do so many things, right? You can do so many things. You can create so many scripts to do so many automations. But our focus would be to understand what are required from DevOps perspective. Okay, what are the commands and everything required. Okay, fine. So am I audible? Yeah, but first we will start from the Git. Okay, not from Linux, because that is the first entry stage for DevOps engineers. Okay, any question? Am I audible?
Yes.
Okay,
yes.
sir. Yeah. Please just nudge me so that I know that okay, I am audible. Yeah, in between. Okay. So what tools we are covering? As I said, we will start with GitHub, right? So GitHub is version control system. Okay. We'll explain about it. So for now, I'm just calling this tool's name, and post that we would discuss that what are these tools. So next tool is Jenkins, which is continuous integration, continuous deployment. Then Maven, which is build tool, SonarQube, code analysis, Docker, Kubernetes, where we would be making containerization apps or artifacts also. Okay, we'll discuss. I know these terms could completely be alien to you, but just hold on, because we would be going one like all these we would be covering them once you would understand everything, and then we would painting a full picture. We would be running the projects, okay, so, using all of this. Then we would have Ansible, and then any cloud platform where we have to do the deployments. Now the thing is, you can also use these to configure your routers, right? But the thing is, because now we are moving away from the on-premises environment to the cloud environment. So the most deployments would be done on Azure. You can also do it on AWS side. I would help you to demonstrate it, like how can you do it on cloud side. We would also touch upon Terraform, okay, because that is what it is used to deploy nowadays. We will see how the Terraform coding is done. I have not mentioned that because we will run it as a project. Terraform is a big thing. There are so many clouds associated with the Terraform. So I cannot write Terraform because then it would itself become a big topic, right? But we would be using Terraform templates to create the virtual machines, to create the resources, firewalls, NVAs on the Azure, okay? And then we could use any monitoring tool. Like there are many, and you might have seen like Nagios is there, Prometheus is there. So many monitoring tools are there, right? Splunk is there. So out of these, we could use any monitoring. Linux, I mentioned, I would yeah, so we will cover VPC. So in Azure, VPC is called virtual network. Okay, so yeah, we would be creating virtual network. We would be creating load balancer using Terraform. Okay, so that is part of it. And similarly, similar products you can create in AWS also. Okay, any questions?
Yeah, so one thing. So what
Yeah.
will be prerequisite knowledge for this to learn, like any specific, or it's
A prerequisite is that whatever you are IT engineer, that's it. Because at least if you have worked somewhat, I know, because this is an introductory as well as like I would say DevOps course. So I would understand that you don't know any of this, right? Or probably know somewhat of this, right? probably Azure. That is why I ask you, like, if you're a network engineer, probably you might not even heard of these tools, right?
Yes,
or somewhat, or some engineers might have even worked on Jenkins, probably some have worked on Git or GitHub. So I would expect that we are starting from the scratch, as fresh from I being the network engineer, right? So I would take it that way, and we will just go slowly. We will cover each of them, right? I would also correlate it with how we do it network deployment, and that is that would be benefit for you because I have that background. Okay, so yeah, so we will just go. So again, we will not teach you here Python. Okay, the same thing we explained in the last. We can use the I have some working experience with Python as well. So we will use some Python codes to do something and deploy something. Okay, but that does not mean that I would we would be covering Python, because then Python itself is huge programming language, right? So it won't be a course of 3-4 months. It would be a course of I would say years, right? So just think in that way. Any other questions you have? I hope we are good. Write it here because Linux is touching everything. Whatever changes we will make, the Linux would be advantage. So I have not written here, but yeah, we will cover it. Just give me a second. Someone is pinging me. What about AWS? So see, we can, Devinder, you have to understand that we cannot cover all the technologies here. So for example, even for continuous CI/CD, I have mentioned Jenkins here, right? Now there are other tools as well, like Hudson is there, right? There Azure Pipelines is there, right? There are so many tools for one specific thing. Like I'm taking here GitHub, then you will see GitLabs for GitHub, right? You will see Subversion for that, right? So for each thing, you would have even in production, you would have so many different, like for Maven, right? You would have Grendel tool. For each case, right? So you could also have that Ansible itself is not getting used. Rather, they are using Jenkins itself to do the large deployments, right? So you would see so much possibilities. Okay, so just think in this way. It is, you have learned so much Cisco, but now the new company you're going, they're using Juniper. It is itself so much large technology, so we are just starting. So the expectations we have, because giving the time, if we will cover we will try to cover everything, then we would miss an important part, right? So we have to also be wary about it. We can create, I can give you ideas how you can create the AWS, like how can you create the AWS account, but then deployment you have to ensure, like we use Terraform, so I can explain that how can you use the AWS Terraform code, right? But here you have to also do some weightlifting, because everything cannot be covered, all the tools, right?
Yeah, understand.
Yeah.
So actually, my question is, 70% of market, uh, owned by AWS. So
no, not right now. It is 40-30 now.
Okay.
It is 40 AWS, 30 Azure, and I think it's around 17 to 18% GCP. It was starting when it was 70%, when Azure entered, so they were like around 70 to 80% capture. But now it has been distributed quite a lot. Now they are just 40. Like I know they are market leaders still, but yeah, other people are also catching, like GCP and Azure especially.
That's why I'm asking.
You will see a lot of job in Azure, AWS, all. So don't worry about it. Even if you have learned about Azure, see then what I have experienced is that the way they are being used, the tools which are being used in Azure and AWS, they are similar. The naming is different. The way you will see how they are working, actually they are mostly same. Different names. Like in Azure, as I mentioned, in AWS you would have VPC, in Azure you have virtual network. Right? The naming is different, the concept is same. The way you creating Terraform script, it would create it the same way, pipelines now, right? So
then it's again that Cisco or Juniper. You want to learn routing, so you have to pick one, either Cisco or Juniper, right? You cannot say no, I want to understand routing on Cisco and Juniper both. Then it would become like then you have to also worry about time, right? We mentioned we have to cover it 3-4 months. Any questions?
Yeah, got it.
Okay. We don't want to miss anything out of whichever is most required, just to fit in any additional thing which can be compromised. Okay, like we would need a sample from each batch. Okay, rather taking two samples from one batch and ignoring the new batch itself. I hope you understood, right? Okay. Okay, so I'm just giving this in advance so that we are clear on the deliverables. Okay. So these were I was talking, right? How we were doing the deployments earlier. So this is about culture, a cultural touch, just so that you understand. See these names being used, so you should understand these tools, at least not tools I would say in detail, but at least these methods, what when they are saying no, we are using Agile, we are creating a sprint, we are creating dashboard in the Scrum, right? So these things you will know, you will see talking when you're a DevOps engineer. So understanding is required. Okay, obviously you would not be involved in this, but you would get the sprints, right? You would see something known as Kanban board or the Scrum board. You would engage with Scrum masters, right? Because these are the people who are the project managers or facilitating the project managers, right? Scrum masters and all. So and some understanding is required. So I'm just covering. So this is what the waterfall model we used to use earlier, right? In our old system, this is called waterfall model, right? We would go to the customer, like most the project team would go to the customer to gather all the requirements, facilitated by architect, understand the requirements. Okay, then whatever design requirements have been gathered would be shared with implementation team, and they would be implementing the solution. Are you like getting some voice distractions from my side, or am I clear? Like,
sometimes it's break, sometimes it's break.
Yeah, sometimes it's getting restriction.
Okay, just want to understand. Yeah, probably because of network or my headphone. Okay, so then it would go to implementation team. After that, implementation team will implement it. It would be verification or testing team, you can say. Okay, and then would be a maintenance. Like maintenance means your operations team would be doing. And any stage, if there is a failure, any stage, if the work is not done, it would again start as a waterfall model. So again, causing redesign, causing re-implementation, right? Waste of time, waste of efforts. We covered it all. This is our old model, right? It is going next. Yeah, Agile. Now this was this is the like model which also running now. Like so, DevOps is almost similar to this model. Is that we any deployment or anything which we are developing now would be broken into small codes or small parts, right? We would not do large deployments because large deployments generally break the things, right? So how we are going to do is that we are breaking the implementations, we are breaking the code deployments into smaller chunks, right? And we call them in the sprint, right? So for example, we want to make a big application, but for now we are just releasing one feature. Okay, so for that feature there would be a team, for example, there are 50 people in the team, so probably 5 people are working on the sprint one. Okay, and what they will do, they would For that specific code, it has 10 features. I'm just taking it on high level so that you understand. So if the application has 10 features, okay, 10 different releases dates. So what will happen that one feature development would go to a team one, right? And they could call as sprint one. Okay, so they will follow all the processes related to like whatever we have seen, right? Plan, design, deployment, test, and review, everything. But that would be the one sprint, means one team formed of 5 people, timelines of 15 to 1 month, 15 days to 1 month. They would be working only one functionality of the application on one specific feature. Similarly, team 2, they would be working on another feature parallelly, or it won't be like no, we are doing the complete project implementation from the start, and then if it breaks we goes to stage 0. No, we are distributing the work in smaller chunks. All we have formed different groups, okay, and all groups are working similarly at the same time, so no time wastage. And if one specific feature has issues, at least all other features would be deployed on time. Got it? So that there is no major so one feature could be that is not ready, so we could deploy the 9 features out of 10. One feature we could say, okay, we would be releasing it on this specific date, and we would be focusing, the development team and everyone would be focusing on that sprint especially. Any questions? So you know, right, how the word comes, sprint is from marathon, right? So if you are running a marathon, it would never happen that you are continuously running, because you have to cover, for example, cover an entire city, or you have to cover like some specific 25 kilometers or 30 kilometers. If you will keep running, right, you will break down some point. So what you do a sprint of say 15 minutes. I would run for 15 minutes, wait, drink glass of water, again second sprint, right? This is how we have to cover large distance, right? So we have to do a large deployment, so we are doing it in the sprint. Okay, small run instances. Any questions? Because you will see this a lot when you will be working. So just to cover you, and there are different tools for that. There is a tool called as Jira. There is a tool called as Confluence. You can create these dashboards in even GitHub. I'll show you. I'll just give you some basics of that, so that when you would be working, you would understand these tools. Like Jira tool is there, and like some would be using Confluence, GitHub, and all these tools, right? So we'll see. Any questions till here? Okay. So you can read through. I have basically covered somewhat like basics and already explained. So these points you can check because our focus mostly is not on the culture. Mostly we would focus on the tools. But yeah, so these are the differences you can go through. So as like in Agile, you can see it is sprint and then it is reiterating. Okay, so if one specific function is going bad, we are reiterating, but all other 9 functions are deployed, right? So just think it's very fast, obviously, because now you are working parallelly. Different teams are working parallelly on different features of the team. So obviously it would be deployed fast, right? Now DevOps, as a DevOps cycle, right? Now so Agile and DevOps are somewhat similar, okay, but very small differences, okay. Tool sets, whatever tool sets are using, so we'll understand that, okay. So as you can see, DevOps is not a single person job. I told you, right, there would be a team, because there are so many tools in the DevOps that not even single person, probably working for say 10 to 15 years on DevOps, would have a good understanding of all the tools. But like I would say that you have to spend a lot of time to understand each and every tool. So it would be very difficult for each person to expert it in say within 1 or 2 years, right? It is a continuous, because DevOps says CI/CD. It is continuous integration, continuous development. That's what it is, right? You have to continuously develop yourself also. So So this is how the stages, we'll cover these stages. So continuous feedback from whom? Now this is where it becomes interesting. Now there is no fight. Operation team is complaining that, okay, we are seeing the issues, and implementation team and design team saying, we have already delivered the solution to you. Now it is your responsibility to support the customer. We are not stakeholder. No. Here, the operation team is giving the feedback. There are bugs in this application. There are bugs in this code. So they are sharing or the design team, right? And design team will take those feedback and will relaunch the new version of that code, right? So it is not that we are not, so everyone is in the system. They are giving the feedback, and those feedback are fixed at the revision, right? So that is why, like, it is everyone is engaged here. It is not us versus them. Okay. So mostly, yeah, obviously it starts with culture. Without culture, you cannot use the tools, right? So tools are obviously from network, like if you say from the technology perspective, these are tools. But if you will see the overall outlay of DevOps, it is basically these tools are supporting a culture. Okay. So this is very important slide, and the next slide I would say. So for example, this is how the pipeline you will see. Okay, so first there would be a project manager who would be gathering the details, project details from customer. The project manager is the guy who would be reaching the customer, understanding his design requirements, understanding his project requirements. Okay, so DevOps would be mostly product specific, not project specific, I would say. So there is a difference. When you are working with customer, he would mostly talk about his product, right? He could have some application or something, but that application could have different tool sets, different skills, or different systems within it. So for once establishing one system, you would run one project, right? But from DevOps perspective, we work on product, not on project. Okay, so it is not project configuring Cisco routers. No, it is project creating application for customer. Cisco router is just one piece of it, providing network reachability, connectivity to the data center. That's it. Okay, so it is a broad, like I would say, broad term. Okay, so the project management team will learn about the product, what is the requirements. Then they would gather all the requirements. They will and obviously when we say project management, they would be architect as well. Then they would be gathering all the requirements, documenting them. Then they would be creating, what to say, work items. Okay, now I'm also bringing culture here. So they would be creating work items either on what to say. So I told you about tools, right? Like either Conference or Jira. So they would be creating work items on Jira, that this is how our plan is. They first they would be working on the timelines, how much time is required, how many people, how many different projects would be under this bigger product, right? And they would be creating this Jira board for everyone. And as I said, they would be breaking the features of application, different features of the application, feature 1, feature 2, feature 3, who is working against feature 1. Okay, for example, I'm just taking the names from you guys only. So for example, from feature 1, Adrian is working, right? Adrian, Devinder, and Himanshu is working, right? For feature 2's, other set of people are working. So this way they would for each project, like a project which is associated with the product, they would assign the people, and those people would be responsible. They would be given a timeline, right? And they would be working on that specific, and they will call it sprint, right? So this is how it would happen. Any questions still here? Okay, so just a minute. Yeah, so what will happen is that when the dashboard is ready, we have a plan, a complete cycle of of the product development is ready. Okay, and it would be evolving. So it is not that one time it would be that okay, this is how it is. Based on the stages of how the work is going for each feature, there would be, so as I said, there would be scrum masters who would be engaged. So they would be coming and discussing with each team, project team, that how is the progress, what are the constraints, right, where it is failing, what we can do, and then they will share this feedback with customer. Okay, because they are reporting to customer, right? So these are the struggles we are facing. Customer would be in continuous loop. So that is why there's a delivery pipeline, because everyone is working in pipeline and there is a continuous feedback to the customer, right? So he knows exactly where we are in the stage of development, right? Now, what developers do? Developers write code, right? So whatever. So when I'm saying DevOps is actually is what to say, independent of the code, right? So what happens, it depends on the architect. He would be deciding what programming language they would be using for developing a project, right? A specific product. So it could be that they would be using Python. It could be that they would be using .NET. So it all depends on architect and how they decide, and then they will hire the people specific what programming they require, right? So again, there would be different developers based on the different projects requirement, right? So, and again, on the backend, what they're using, in front end, what they're using, it would be entirely different. It would be dependent on based on the product and what they are trying to achieve, right? And that is why DevOps does not matter what programming language they're using, right? It is independent of the programming language being used. Okay. Now, whatever codes you are, so for example, you as a developer, like not you, I'm saying the developer, there are 5 developers who are working on feature 1, right? Now, how they make sure that whatever changes they are making, okay, they are getting saved somewhere. It should not happen that whatever code you written today, you gave 8 hours to write the code today, and something, your laptop is crashed, right? Then what will happen? Your code is gone, right? Your 8 hours of effort one day is gone, right? No, it should not happen. And also, because you 5 people are working on one feature of the application, you don't know what are the 4 people are working, right? Because you are not able to track of what work they are doing. So whatever, whenever we are working in in the development, we follow something called as source code repository, right? We'll talk about it. So the tools we use here is basically Git. Okay, so we will use Git for tracking whatever changes. So we could use, for example, Virtual Studio Code as a tool where we will write our code, right? Or it could be Eclipse, it could be Atom, anything. Like you might have heard, even for Python, there is PyCharm, right? So these are the different tools where you're writing your code, right? So and that code, whatever you are writing, is first on your laptop. Then it has to be updated on some distributed centralized system, where so that everyone can see what you did today, what changes you made, right? And then it should be as per the version, right? For example, 4 people are person 1, person 2, person 3, and person 4 are working, and person 5 are working. Sorry, 5% are working. So person 1 made a change, so that should be saved as, for example, because person 1 made his part of the changes and he want to publish it or update it on the central system, that should be showing as version 1, or some with some identification that okay, this is version 1, this was done by person A or person 1, right? And similarly, if person 2 comes after 5 minutes of person 1, and he wants to publish his changes, then his change also should integrate with the previous change, but his changes should be tracked as version 2. And you can see, okay, what lines person 2 added, so that if there is some break in the code, you can roll back that. Okay, so that is called a version control system. And in that, we save this codes in something called as Git, and from Git we connect some central repository where these codes are saved, which could be GitHub, which could be GitLabs, which could be as your repo. Okay, so all these, there are different tools, right, in the market. So yeah, we will be covering GitHub here. Then it would be compilation. So whatever code, whatever language you have built the code, probably in Java or .NET or whatever. So if it is Java, for example, so you would need, so you cannot do that. Okay, my code is ready and run, boom, it will run on the server. No, server would not understand it, right? So first you have to compile the code, right? So that server can understand the code, right? So you have to compile. For compile, there are different tools I told, right? Maven is there, Grander is there, and similar other tools. And these tools are basically plugins which you can run on some like tool, CI/CD tool called Jenkins, right? So we'll cover those things. After compilation, when your tool is like your code is ready, compiled, it is compiled, you have to run some tests on that code, whether it is working as planned. Is it going, following all the, like whatever, like code goes through different tools, like it has to call some database, call some APIs, right? So different stages of the code where it has to, for example, there is some code where you want every 1 hour that you get the temperature of say, for example, US. Okay, for every 1 hour you want to get the temperature of Australia or different cities, right? So you can use, so there are some APIs which actually gives you the temperature of different cities. So you can call these APIs, you can run a program which invokes these APIs, and you can use some loop where every some using some cron jobs or something. We'll talk about these cron jobs and everything, where you would run these what to say, these codes periodically 1 hour, and it will fetch the temperature using the API calls to the specific server, and you would see, okay, what is the temperature of the city, and probably you want to get a message, right? So for getting message, there are different APIs, right? So you can invoke those APIs, and so that you get a message on your mobile, or you get an email that, okay, this is the temperature, and you can use it for different use cases. I'm just giving very simple example that how these things work, right? So these are the different stages. For example, if you're not able to get the temperature of API, the API. So you are testing it in the test stage, whether it is working. So that happens under the unit testing. Then packaging, you want to make an artifact of it, so that you are making a package. You cannot directly run the code on the server. If there are, say, for example, 10 servers, right? So it is not feasible that you will just have that code copied and put on the server. No, you have to build the artifacts. You have to build it so that it is in a package which you can, for example, any software you download, right? It is a package in which you would see there are different files, right? So so that forms a package, and that package, there are different tools, right? Then server provisioning is there, where like you would be creating the servers, right, where you would be deploying this code. It could be on different so for example, you want to deploy 10 or 50 or 100 servers, right? So it would not that you will go on AWS or Azure and say server 1 configure, server 2, and you are giving all the details. No, it should be automated. We want deployment, this code, 50 servers, 50 servers. We are running the template, boom, 50 servers created, right? Whatever, it took 10 minutes or 15 minutes, but created, right? So that is what we are creating, the infra now. Okay, all the parts of infra, like if we are deploying the 50 servers, we have to configure a virtual network or VPC in the cloud. And like if we want to enable some firewall security, either in security group rules or whatever, so you have to create the templates either using Terraform and whatever, so that we can deploy these infras using template. And that's what I said, that when we configure the routers and everything, we go manually and enter the configuration. No, we are maintaining a template. Okay, we are maintaining a template in either Virtual Studio Code or whatever. Like it could be different company using different tools. But for example, Virtual Studio Code we would have a templates. Okay, we want to create the server for this specific SKU. So this is a template. So whatever, if you are creating one server, or if respective we are creating 100 servers, the configuration is exact same. If we are looking for SKU, there are no deviations in the configuration. Hence, we are not breaking the things because everything is as planned in advance. Okay, any questions here? Then our code is ready, our servers are ready. Now we have to perform. So for example, I just said you that our code will just will go give the API call, will fetch the temperature, and it will display send the message or email. If it is for one user, you can even use any no code application or whatever because it is for very few users, right? But what if it is for, say, billions of users is accessing that data? For example, your mobile, you would see something temperature. This is the temperature, right? Or what is the time? What exactly is happening? Your operating system is actually calling some APIs in the backend, and then fetching the data and showing to you, right? And now different companies would have contract with different API provider for that, right? Or they might have their own servers also. But you can imagine, right, if there are billions of users, you cannot have one single server, right? So you would have a lot of servers, and then before making any changes, you have to test it whether whatever, if these users, if like you will behave as is that there are millions of users who are sending the traffic, whether these number of servers, like for example, you deploy 20 servers, whether these 20 servers would be able to support that much load or not. And that is how what is called as load or performance testing, okay, for your application. And once everything is done, the testing is completed, then your code is ready to release on the production servers. Any questions still here? Any questions, guys? Okay, no problem. Am I going too fast, or is it like you are able to paint a picture what I just explained, or do you want me to cover anything, any specific part of it?
Yeah, so this entire thing will be on cloud side, right? Like whatever these things we are going to deploy, or the testing, the unit test, and server provisioning kind of thing.
So let me answer in this way is, now because you are moving from traditional network or traditional setups to our next gen, like who's working right now, right, or would be working in the future. So every aspect of it has to be whatever is being used, right? Obviously, you can replicate this model to configure your on-prem servers as well, but that's not what the current technology, what's happening in the current technology era. Mostly all big customers, right? I would say mostly all big customers are creating deployments on cloud, right? So obviously you can configure your routers. Obviously, the process would be same. You would need network reachability, and you have to identify that what are the different plugins you have to use to configure some router using the pipelines, right? So, but you can do it. You can do it, but the thing is, because in today's era, the major deployments are happening on the cloud, so we are focusing mostly on the cloud only.
Okay.
Okay. Any questions? But again, like you can use the deployment for the on-prem deployments as well. It is very much integrable, so no, nothing to worry on that one. Just a minute. Let me go to the next slide. Okay, so these are the different tools, but I will not cover here. Let me go to the next slide. Okay, this one. I hope it's visible. Oh, sorry. Okay. Okay, so these are the tool sets. Okay, so we will start from the left bottom. You can see project task management. I said, right, a project manager would be reaching the customer. He would be gathering the project details. Okay, and based on that, he would create some work items, right? He would understand, he would record the project details somewhere. He has to create a blueprint, and he would decide how this project timeline would be expanded, who would be working on this, who would be managing what unit, how would you track that. These tools are called project task or project management or task management tools, right? So Jira is very famous. If someone is having some background in this, you might have heard Jira or Confluence. Okay, Atlassian Jira, right? So this is one tool. We can create these dashboards in GitHub also. I'll show you. For example, I'll just show you. But for now, let me cover this slide. I'll show you that how we can see those. Next is deployment and configuration. Now, um, like project management team has gathered all the details. Okay. Now, next stage is that you have given the details you have decided your engineers, your developers, that you would be working on this specific thing. This is our requirement, that we have to build an application. You would be calling the APIs, fetching the time, sending the messages to customer every 1 hour. For example, I'm just taking an example. So one specific feature of it, and probably there are two features. You also want someone to actually message these guys kind of feedback, that did you get the correct temperature or whatever, do you see that, is it right or not. So it could be a second feature of the application, like n number of features application can do, right? So for I'm just giving one example, right? So, or example, you want to also give the wind direction, right? How is the wind direction? So that could be feature 3 in the application. So you are adding up those features in the application, and you are assigning for each for feature, you are assigning the engineers. Okay, this engineer would be taking up this feature, right? So they would be writing code somewhere for that feature, and this is where they would be maintaining the configuration or the code. And mostly, like whatever most places I have seen using Virtual Studio Code, it has a lot of plugins as well available. So it is like very well penetrated tool. So I would recommend you, like, and we will use this, okay, for our use case as well. Obviously, we will not write any codes. We will copy codes from somewhere, and we will try to run it. Okay, and we will show, okay, on VS Code. And like I would also request you, like, if like you want to run something, use the VS Code, not any like, just because it is very easy, right? And used some almost everywhere. So I think it would be easy for you to ramp up when you would be working, right? Then once the code is you are writing the code on your local system. So this tool would be a locals on your local system only, like on your PC or your whatever, wherever you are working, right? So then next would be source code repositories, is where so as I said, like, one feature 5 people are working or more people are working. Now you have to maintain some consistency, right? Version control system. You have to know, each engineer should know what changes other engineer made, and they can also verify the configuration. For example, engineer once or developer one goes to developer 2, whatever work I'm doing, you just back test it. You go through the configuration and you see if, like, there is something. And same developer 2 says to developer 1, so they are supporting also each other. Then how they would do it, that they have to use some repository where they are able to save that code and can see the code of each other, right? And also can amend the changes if they see there is some problem. Okay, next stage is that CI/CD stage, and you see a lot of gears moving there, right? Because this is very important stage in DevOps. Okay, and this is where you would have so many plugins installed, right? I mentioned about Maven, right? I like the build tool. I mentioned about the testing tools like Selenium. or static analysis tool like SonarQube, or packaging or artifact tool like JFrog, Artifactory, right? So these are the plugins which would be running on Jenkins. Okay, so it would be Jenkins servers where these things would run as a plugin. Okay, and Jenkins would do the integration. Okay, so all gears moving together. Okay, so think of this. That is why, like, just think in the one gear could be build, another gear could be testing, another could be artifact, right? So these are, and then one gear is Git. So they are continuously moving like as a pipeline or something like that. Okay, just understand that is why the gear is placed there. Post that, once it is ready, now once the package is ready. Okay, so in packaging, right, artifact, we are creating the packaging of whatever code we have written. Next stage is we would be now we would be testing. Our code is ready, our package is ready. Now it would go to the testing team, and this is where you have to understand that we would not probably would not be working full-fledged. So we might have some understanding of these tools, okay, but there would be people who would be actually doing the testing of this. Okay, and DevOps would not be that guy. They would work, they might have some understanding. Obviously, you can go in detail about these tools, but DevOps mostly would sit with them. You gather some understanding of these tools. So they would see, okay, how this application is performing when like in test environment. So performance monitoring, there's called very famous tool called as New Relic, or App Dynamics also being used. Load testing, right? We want to ensure that if what happens if there is, for example, 100% load, okay, as per your capacity. What happens if we give 150% load on this? How the application behaves? All the observations would be logged on to the monitoring tools, right? Because you would want to know what alerts are getting triggered when the load is 100%, what alerts are triggered when the load is 150%. What is your scalability of your application? Because see, when the users are coming, it should not happen that your system should be able to scale to a certain limit, right? It should not happen, no, my system is just, it would support 100 users, and if 150 users comes, everything fails, right? No, it should not happen. You should test it, how it would behave if 150 users come, right? You should have that that leverage. You should have that additional capabilities and test it in advance, so that how it behaves well when it goes into production, right? So there are some tools, JMeter and Gatling for that. Then once your software is ready for release, you want to check it in the Selenium. How is the flow, right? How would user, like for example, you go for some booking site, right? For ticket booking site, for example. So you will go in stages, right? You will first choose the date. What is your travel of journey? What is the source? What is the destination, right? And whether you would be traveling economy or premium. So these features. So how a user is behaving on the application, right? So what Selenium is just that it would behave in the same way. It would be automated, and it would be seen whether how a user is behaving on the application is, for example, if user is able to create a ticket, a travel ticket, so your application in testing environment would be tested, so that it would be tested like a user is requesting for a ticket, right? So it should be able to give an output as a ticket, and that is your software ready, right? That's how your software is ready to book the ticket, and that's how it should behave. So that is what you have to test it in Selenium environment, right? Next stage is production environment. Somewhere you have to deploy this. It could be either on Azure, it could be on AWS, right? On the cloud, it could be on Kubernetes, where you are creating the pods, right? It again a very huge technology and very much in demand. Okay, so this we will not cover this Kubernetes. Okay, we will just try to give you some understanding about it. Okay, so there is like you get some idea. then you can also deploy it as a VMware cloud environment, right? Because on VM, some might still be using the VMware images. Okay, so but our focus is mostly, so we are taking one thing from each sample is, so we are taking obviously be integrated with monitoring tools. On the top you can see, right, there are different tools, Nagios, Splunk, Grafana, and Prometheus, right? So we will be taking one of them, and after this there is a sign off. Any questions still here? Any questions? Because this is very important slide and I want to ensure that you understand. Just give.
So these all are kind of GUI tools, like or how it is, like some of them are CLI or.
Hello, am I audible? Hello.
Yes.
Sorry, I missed. I think someone was asking something. I was just having a sip of water. Yeah, can you come again?
Yeah, so these tools, whatever are there, Prometheus and Grafana, Splunk, Nagios, Maven, SonarQube. So all these are graphical user interface like GUI tools or CLI based tools or kind of things.
Mostly they are GUI. Yeah, you can also use them. Like in Jenkins, you can use the pipelines creating somewhat CLI as well. So we'll cover that. Don't worry.
Okay.
But also, like for cloud based, I would say, like if you have both options. You can go GI based, and you can also use Terraform scripts, and like, so each cloud provider would have their own different languages as well. Like for Azure, it's ARM, right? You can use ARM for creating any infra. Okay. But Terraform is integrated with everyone, so you can, Terraform is common and open standard, so you can use Terraform to create any instance, any infrastructure instance, either in Azure, AWS, GCP, or any other cloud. So yeah, it depends on you. Like Git, you have mostly, like I would use Git in CLI, but you are having Git GUI as well, so you can use that. Jenkins would be like, it would have what to say, GUI mostly, and then you can, in GUI you can create pipelines, you can run the cron jobs and different integrations, as I said, different plugins, all in GUI you can do it. Okay. Similarly in Azure pipelines. Okay. Docker, you would have Docker Hub, from where either you can deploy your like images, whatever package you are creating as a code, and then you can pull those. You can work on CLI base as well on Docker. Okay. What else? Yeah.
Sir, what is the difference between Docker and Kubernetes?
Very good questions. Actually, just think in this way. Docker is something where you are creating some image. For example, you want to create one application, right, which is using Linux as a code. Okay. Sorry, Linux as an operating system. On Linux, your code is, for example, Java based, right? Java language you are using, and you have written the code for Java. You would require Java runtime environment, right? JRE, so that your code is get executed on JRE. Now JRE would also need some for example, some plugins and everything, right? So you would install those, and you would also need some operating system which is supported, right? So so operating system could be Linux and everything. So for running the code, you would require runtime environment, middleware, your code as well, and some underlying operating system on which, and that operating system should not be also full-fledged. For example, nowadays there are operating systems which are very small in size, okay, because your an operating system can do so many things. For example, our Windows is operating system, right? It has features to show you the GUI things, right? It has option to take the mouse control. It has option to take the commands through keyboard, right? All these are the like different files and programs inside the operating system which are making sure that you can see everything on the screen. You can give you can do anything through mouse, or you can give any printer command output, right? All these are part of the operating system. That is why our operating system size is probably 1 or 2 GB, right, size. But would you use the same operating system to run your applications? No, because you would not need probably mouse, right? Because you just want to run your application. You don't need any mouse commands. You don't need any Windows, any keyboard commands. You don't need to give any printer, right? Because these are all our operating system is for general use purpose, right? So it has all these things, but there are truncated operating systems, right, which are just built for specific code running. So that is where what you would do, that you would use those specific small versions of operating system which are actually optimized for specific type of code run, like just for running Java, right? So what you would do, you would take that operating system image, small image, you would build a Java runtime environment over it, and then you would build like other plugins, whatever you require, and then on top of that, like an underlying, you would use operating system at Linux, and then you would have your code there, right? So all these layers, all right? So what you can do, you can form a package or an artifact which would have everything, okay? So so using that, you can create one image, okay? For example, we have one image. In the image, we just have for example like one image in which we are just running operating system. No, but this image would be different. It would also have operating system. It would also install the Java runtime environment on the server. You would also install all the plugins required for running the code, and it would also install the code. Or you would have just one image, right? And then you can plug in that on Docker, right? But what is the difference in Kubernetes is that for Docker, you would have just one image. Now, if you want to uh, run that image on multiple servers, you have to pull that image from the Docker hub where you will publish that image, and you will run it on multiple servers. Okay, so it is kind of that you have to ensure that that you are making these changes manually. Okay, and if one specific image goes down, or one specific there is some problem, right? So there is no auto healing as well. It is down. But how Kubernetes is different is big. It will take that image, and you have to just supply in a configuration. For example, you want to deploy it on 50 different servers. So what will happen, that image would be automatically, based on the configuration file you will supply to on the Kubernetes, it would create 50 servers automatically, and it will deploy that image automatically on those 50 servers. Okay, and what will happen, it will auto monitor. It will, if some image goes down, it will rebuild it. Okay, so the Kubernetes is kind of a scale solution for Docker. Any queries? So Kubernetes could be on-prem as well, but now all the clouds are offering the Kubernetes solution. So there is Azure, there is AWS also is, I think Azure is AKS, AWS is EKS, and GCP is also offering the Kubernetes service. So all the clouds are offering these services. So it all depends in which one you want to use. Yeah. No. Voice is breaking. Is it still breaking?
It's better now, I would say.
Okay. So anything you missed because of my voice breaking? You want me to repeat?
I will go through the recording. So,
okay. So any questions? So just understand this. Jenkins is very important tool in this entire flow. Okay, obviously everything is important, but Jenkins is kind of which builds. It is at center stage. That is why the gears you see there, right? It is kind of the one who is integrating everything. Okay, and the pipelines would be there on the Jenkins, or like any CI/CD tool, right? Probably it could be Hudson, it could be Azure pipeline. I just mentioned two tools here. Okay. Okay, what time it is? Because let me know, like, if we can start or if it was first topic. Just understand. Here, this stage, project task management would be the first stage where project team management team or Scrum Masters would be working. Second stage would be coders or developers would be working. From here is where the DevOps starts. Git, okay, like source code repository. So this is what we would be covering. Like if you have, like if we have time, we can start. Otherwise, we can also cover it in the next session, like next tomorrow, the same time. How much time it is? Can you tell me?
10:50.
10:50. Almost we have almost covered 2 hours, right? Yeah. So if you have any questions, or let me give some brief introduction. Let's cover for 10 minutes. So so the first stage I said, right? This is where the DevOps engineer mostly work starts is with Git, Git, Azure repos. Like these are different tools. You can use any single of them. So we are taking one from this bucket is Git. Okay. And it works with GitHub. So we will also cover GitHub, but we'll start with Git. Okay. So what Git is called as version control system. So I already told you is that there are in one application there could be different features. So for example, 5 people are working on one feature, right? So they have to ensure that they can see each other's work. Okay, they can see each other's work and validate each other's work and amend if there are any issues in the code, right? So for that, there should be some repository, a common repository for 5 people or even for more people, where whatever work they are doing, whatever coding they are doing in VS Code for Visual Studio Code, that is getting saved, right? So some local repository, and that is where Git comes in. You have to install Git on your local system. Okay. I can show you so that at least we kickstart on first two today. Okay, we will cover obviously in the next tomorrow, but at least we can go ahead and I can show you that how to install the Git. Okay, so I already explained what is the use case. Okay, so you whatever code you are writing, obviously you would be saving it on some folders. For example, some project folder, new project, or temperature application. For example, I mentioned above. So you can mention the folder name application or project, temperature control or temperature indicator, something like that, right? And in that you will have your you will create your new file in Visual Studio Code, give the path of that folder, that this is the folder where I'm writing, and that folder is basically would be tracked by Git. Okay, so whenever so that folder is your working directory. We call it working directory in Git terms. So whenever we are making any changes, any line addition in the VS Code, the code is getting is saved in the folder called project temperature indicator, and from there it would be getting tracked by some software which is called as Git. Okay, so Git is having a local repository. So for example, there are 5 people working on 5 different machines, each would have same folder. Okay, and it would all would have a local repository, Git local repository on that system, on their system itself, and it would be saved on there. Okay, now from there, this is called local repository because we are saving it on local system only. And from there, it also would be pulled by something called a centralized version control system. And the centralized, so there are 2 types, centralized and distributed. Okay, now there is a small difference between centralized and distributed, but centralized is where you are using single central repository, for example, some single server, right? So whatever changes you are making on your laptop, you are writing the code that is getting replicated on server, and everyone, any of engineer can go and check what changes you made today, okay, at what time. So that is the single repository, one tool which is used as subversion. But there is some problem with centralized version control system is that what if the server goes down, right? Because that server has to be managed by you, and if that server goes down, then everyone's work is like you won't be able to track until the server comes up, right? Or something bad happens with server that you're not able to recover. So whatever efforts you made to actually all 5 engineers made, whatever local system that was replicated on the, now the server is gone. It is like the server is broke. So no one would be able to see any other's work, right? So there is one lacuna or one problem with centralized version system. So that is why, like, mostly people, you would use distributed version control system.
Voice go.
Oh, okay. Sorry, just give me a second. Audible?
Yes.
Hello?
Yeah, now audible. Yes.
Hello?
Yeah, now audible, sir.
Okay, okay, fine. So distribution version control system is some. Hello? Hello?
Yeah.
Am I audible?
Yes, audible.
Okay. So distribution version control system is where it could be like SaaS-based system or SaaS-based tool, like GitHub is there, right? GitHub is distributed version control system, where whatever you are writing on your local system in like in some file, which is getting tracked by Git. So what Git will do, Git will talk with GitHub. Okay, so Git is local repository. Local repository is maintaining the local copy of your code, and as soon as you are making some change, because you are making changes in local repository, you are pushing that change. Once you will push that change, that would be replicated on the distribution version control system, which is GitHub. Okay, and once it is deployed to GitHub, all 5 developers can see what changes you made. Okay, and for each other they can track. Okay, so Git and GitHub work together to make sure that we are maintaining whatever work we are doing. Okay, even if we are adding one line, we are making sure that is getting tracked, and there is a specific version associated with that. I know, like, for now it could be all theoretical, but I will explain you how to do it. Okay, so for now we will just close it here. Let me show you how to install the Git. Any questions you have?
Git and GitHub is both different things, right?
Yeah, because see, Git is local software. You will install it on your local machine. Okay, and GitHub is a cloud-based tool. So Git is kind of think of as a client, and GitHub is a server. Okay, so whatever you are doing on local machine, Git is tracking that, and then Git is talking when you are asking Git, okay, whatever changes I made now in last 1 minute, publish it to GitHub, and GitHub is server. Okay, so whatever changes you made, even if you add one letter, say for example letter A, and you want to push that letter A to GitHub, it will push it. Or if you have written thousands of lines and you want to push now thousands of lines, it will push it. So just think in this way, Git is like what to say, client, and GitHub is a server. Okay. Yeah. Just think in this way. You take photos, right? So photos, you have a local camera, right? And local camera, you take the photo and you want to save it on the Google Drive. Okay.
Yeah, good.
Now, even if like you are taking photos locally, that is getting synced on the drive. Even if you lost your mobile, you can go to any other mobile or any other system, log in your Gmail account, and you can retrieve your images. Same way. So Git is that local camera, or it is maintaining like it is the camera memory where your local images are getting saved, and then your mobile is sending it to Google Drive, and there you can also see your images.
So how much data we can store on that one, like any specific GB something or that, like?
No, there is no such limit, because see, whatever applications you're deploying, it would be like recorded on that. So it depends on like what type of license you're using. I have to actually check on that size. I don't have any number for me. I have to also check on that. Okay, but it is like there won't be any limitation, like based on that you would run off that whatever application you are using, that you won't be able to use it, because mostly whatever the big projects you know of, right, they are on the GitHub.
Oh, okay.
You can think of. So you can see there are so many. So even Kubernetes. So if you want to know that Kubernetes, there is a repository for Kubernetes. So their entire development code is on the GitHub. And if you want to see that code, you can go and see it yourself. And if you want to make the changes, so there are few people who contributed to develop the GitHub, right? Open source, because these are open source tools, right? So if you want to contribute or you want find some bug, and there you can open an issue saying that I found this issue and this is the fix. So whoever is the developer or the main people who are contributed for Kubernetes code, right? Because it is on, I can show you, it is there itself on the GitHub. So if you want to contribute something, they will see, okay, what you are mentioning is really a bug, and the developer will validate, and if they see, oh, this is really a bug, they will approve your change, and whatever changes you made, it would be pushed to the main code, and you are a contributor then. So you can even show in your resume that I am a contributor to Jenkins developer team pipeline. Okay, you can show them like to anyone, see, I have been publishing, and this could be added in your resume as well. See, I am contributor here. So you can also show you as a contributor of a Kubernetes development team. And that's how like these people come together, right? It is not like any big thing what you are developing, it would be only one developer working. There would be thousands of people, open source, like if any open source application is getting developed, thousands of smart people working across the globe would handhold and actually work together. That's how it is done. So you can see that collaboration there also. Yeah, any questions? Yeah. So don't worry about it. Like, see, whatever work and labs we would be doing, I just told you, right? We using GitHub. So that you can see, download those, replicate that. I would be updating code, so you can yourself pull it from the GitHub and use in your system, right? Just like Google Docs, right?
Again, voice gone.
Creating, I would. Sorry. Now it is there.
Yeah, it's better.
Hello.
Yes, we are.
Hello.
Yeah, it's audible now.
Just a minute. Let me. Just a minute. Hello, am I audible now?
Yes,
Hello?
yes.
Yes, sir.
So, yeah. So I hope you got it. Let me help you to how to install the Git. I hope you can see my screen, right?
Yes.
Yeah. So just go to Google. Sorry. Okay, we'll go here. Now, based on whatever operating system you're using, as you can see, it's macOS, Windows, and Linux. Mine is Windows. I'll just go to Windows. Or mine is so you can check what is your Windows setup. What is the based on operating system. If you want to check and you don't know, go to command prompt and type system info. Yeah, it is 64, right? Yeah, here also you can see system type 64-bit. So I'll just go and install 64-bit. Okay. It is getting installed. You can also follow me here based on your operating system, so that like you follow me when we are doing it.
We are not going to do any practical of Git on Linux, right?
Yeah, we will be doing it. Practicals on Linux. It is basically, so when we are using Git CLI, it is Linux only. I already have the tool installed, but let me show you how it would look like. So for example, this is Git. I would type Git. So you can see, right, it would install two things. One is Git GUI and Git Bash. Git Bash is CLI version. If you want to use GUI also, but I always prefer CLI. So will because also like you want to learn about the Linux as well. So it would be better to go with this. So I'll just click here, Git Bash. Okay. So this is how it will look. So you can see everything here, like Linux commands, ls. It shows all the directories. List ls means list, whatever folders I want to see. Okay, what is my current folder? I will print working directory. It shows pwd command. Okay. If I want to create anything, any folder, so I can use nano. sorry, I can use touch, and if I want to say create some folder, for example, I was talking about temperature project, a file I'm creating, temperature project.txt. Okay, so my file is created. Now if I want to check if it is created or not, let's you can see, right? You can see that it got listed. If you want to see all the files and see yourself if it created or not, I will say list, and you can see temperature project is created here, right? Now, so all I'm doing is from the Git CLI. This is all Linux, okay? So if I want to now track this file, if I want to make these changes in this file, so there are commands like you can use Vim, or you can use Nano, okay? So for example, if I want to write something in this file, I will use Nano and temporary project. We can use tab to complete the name. Okay, I'll just go inside. See, I can write it here. This is okay. Now I added one line, and I will save it. For saving, I will do Control and O. You can also see it down, right? Control O means write out, write and come out of it. Okay, so I will say Control O, and I will come out of it. So I will say enter, Control X. Okay, now if you want to see really did whatever I have written, is it there? So I will now go to this folder. Is this okay? I'll just go. Where is the path? I think it was in C. So let me go and see. Yeah, projects, Terraform. I will see from here in only print working directory. Let's see users. Where is it? Right.
Just copy the path and paste in the browser, and it will automatically open.
Yeah. That's what I was doing. Oh, it was in OneDrive. Yeah, see, it came here. Okay, so I wrote that one line, right? You can see it. So yeah, so we will create a new folder. Okay, if we want to create a new folder, we can create it. Okay, and if we want to move any file, we can do it. But all of this we will cover in the next session. We'll create a new project itself, and in that we will just save it. Like for example, for Linux, if you want to also see how can we do another ways, we can use VI. Okay, VI is again another. So Nano is editor. Okay, we can use VI also to edit. So tab. Let me make it a bit bigger. Is it bigger now? Okay. So VI. Now see, this is my first project. For example, I want to add something else. So I cannot edit it until I go into mode. I have to press I. That is why see it is not take. Now I went to I mode. See it is taking. Otherwise you cannot make any changes. Okay. So I have to go to insert mode here, and whatever mode I am in, you can see written below insert. Okay. So I have to press, and I can write this is I second. Okay, now I have to press escape because I want to save it. Okay, just a minute. I have to press escape. Okay, I came out of insert mode. Now I have to for writing this file. So as I said, different editor would have different options. So I have to write WQ. Okay, write and quit. W means write, Q means quit. Okay, so again my file would be modified. I will go print working directory. Okay, I'll just copy this, Control C, and yeah, anyway we are here, so you can see, right, both lines came. So this is how we can do it using Linux. Okay, so for today I think we can conclude, and tomorrow we would be working with how we will actually track it using Git. Okay, any questions?
No, sir.
I hope you liked today's session, and if you have any queries, you can let me know. We can conclude for today.
Yeah, thank you.
No problem.
Mm.
Can I stay with you?
Please, Tran, we need, it's possible to take the plan of DevOps course, if we can have the plan, and also I would like to know how long will take all the training.
It would run from 3 to 4 months. So I'll try to cover in 3 to 4 months. Yeah.
It's possible to get the plan of the course.
Plan, yeah. So for that, I will discuss with with Arjun. Probably Arjun reached to you, right? Or Gaurav?
Okay.
Yeah. No, I'll discuss it. No, don't worry on that. Like anything which is like as I said, all the course content I would be uploading it on the GitHub, so that you can yourself. Let me also show you GitHub before I go, so that you understand what I'm trying to say. So, for example, this is GitHub. Okay, so this is my GitHub. If I so here is where I will create new repository. Okay, and I will keep on putting all my content here. I will make it public.
We are not seeing the screen actually. I guess you.
Oh, sorry, my bad. Just a minute. Let me share my screen. I hope now you are able to see my screen. Yes?
Yes.
Fine. So this is the tool GitHub. Okay. This is the central repository I said, right? Just like Google Docs or sorry, Google Drive. we are saving all our images. So whatever work we are doing as a code, we can do it here. We can save it. So for example, I am taking this repository. Someone created a deep packet inspection code. Okay, so you can see here. This is the code. These are the different files. Okay, and about this, if you want to, he has also created a README file. Okay, so README in there, you can find what this code does. Okay, so how to use it and everything. So this is deep packet inspection. Goodbye DPI, deep packet inspection circumvention tool, which is built by which is actually, as you can see here the codes. Okay, so public. If you want to see the code inside, you can go inside these folders. These are the directories, and you can see all different files inside, right? So there are different codes you can see, right? So many files inside. Okay. You can see who made changes recently. So here you can see these are the changes made recently, and all they might be pushed from the Git. Okay, so if you want to see what is the change, so this was the change made recently. Yesterday it was the change. See, you can see ++ means only these 3 lines were changed in the code, right? So because of these problems, they made some modification in the code. So it shows green, more changes were made. Okay, so similarly, I was talking about issues, right? You can raise an issue saying that we are getting some problem. And for example, I am just taking someone raised this issue for this code. This is open platform, so you can also patch it. How you do it is something called as fork. I will show you. There is a fork request. You will pull it using fork. You can actually replicate it on your. So you have to create your own directory, but using fork you can pull it. So it's saying I run it as regular person. Okay, when I'm trying to use something, it appears 504 error appears in the program mode. He has shared a snapshot. Okay, and now this is an issue means it's just like a ticket. Okay, now the developer will see this and will try to understand what is the problem and will fix it. So just to give you
yes, so it's something like the program will be created. Let's say you created the script and the program, and which is open to all, like anyone can use it. And if they trying to use, if they found any issues, they will just mention you like, okay, these issues, and you
also, like if they want to so issues is like if they experience some issue using this code, they will report under issues. But if they want to contribute, for example, they know how can, like, because developer has to investigate it, right? So for example, you found some problem, this is my code, and you found some problem in this code. You first is you don't know the fix, right? So in that case, you will go under issues and raise the issues, right? But if, for example, you know that what is the problem, right? So you can create a pull request in that case. Okay, but mostly this is done by developer only. Okay, so you need to create new pull request, and you would say I want to create a new branch. So in this branch, you would say I see I don't have access, right? That is why it is it is actually only for developers who would have access to create pull requests to make the changes. But like if you want to become as a contributor, you can reach the owners and say I want to also contribute to this project. So they will have discussion, and if they are ready, you will also given access to actually make the changes. So you can create pull request. Pull request means that you would be able to modify this. So see, some developers made some recent changes 18 hours ago. So we can see what changes he made in the pull request. So we can go to quick blog. Okay, and you can see, right, all these minus red lines you see is the code which got removed. All that green lines which you see is the code which was added, right? You can see, right? So much changes in this one deployment. So you can see all these things, and these are the versions. So even if see same user made changes, multiple changes here. Okay, but in this line, in this change, he made some other changes. He just made model -9 the default instead of -5. So this change he made under this version. So if see, this version goes gives some problem, we can roll back. So we know that okay, these are the versions which were made, and these 3 files were changed. Everything we can track from here. Okay, just to give you a perspective. And like if you want to see who are the developers, if you want to reach, you can see here contributor somewhere. Just a minute. Yeah, here. So there are 12 people who are actually managing this code, like who are the developers. So they are collaborating. So how they are doing, they are not writing it directly here. They are having this, they are using Git. Okay. So what they are doing is, for example, this is what I'm using a Visual Studio code. I'm just giving you an example that how we do it. So for example, I wrote this Terraform script. Okay. And this Terraform script is getting saved somewhere. You can see, right? C projects chapter 1 Terraform. This is the script where it is getting saved. Okay, so if I go to this place, C Terraform, C projects. Yeah, this is the folder, right? You can see this is my folder, and this is my main.tf file. So I'm making changes in this file, and if I want to track this, I would do it simply. I will go here, okay, and cd. We will cover it in detail, but just to give you what happened. Or we can also do it from here. Show more options. Yeah, I'll just do git not GUIs. Sorry, I will just do show more options. Git bash here. So I will right now. I'm not tracking this folder. So whatever changes I'm making, these are all local only. If I want to make sure that I am tracking is using Git. So see, I am in this folder. If I want to list ls, so it will show all these files. Main.tf is there. Now if I want to track it, all I need to do is init. Okay, initiate. See, now a folder would be created here. Okay, let me refresh it. What happened? But we will be covering it more.
Yeah, we'll be covering these things in detail, right? Like
yeah. So you can see that .git folder is created there. So it is a read, like it is a hidden folder. Let me check again. So now this folder is getting tracked by Git. So whatever changes I'm making in this folder, they would be pulled up by Git. I'll see why it is not showing here. Yeah, because it is a always hidden folder. You cannot see it like this. So how do I change the properties of this? Yeah, hidden items. See, you can see, right?
yes, yeah.
So now earlier this folder was not like this folder was not getting tracked. Now this is getting tracked by Git. This Git is tracking this. So whatever I'm making changes, Git is tracking that, and if you want to make this project push this project to here, I want to make my own directory and want to push that code there, it could be pushed. Just to give you also start at your level. Okay, so for example, I was talking, there is a what to say, not Terraform, Kubernetes code. Kubernetes. So we can search Kubernetes. It will show Kubernetes. Yeah, this is Kubernetes pipe. So there are different pipelines. We see different people have created. So this is a course. Development Kubernetes. I think it is project. So you should know the name of the project to search it. I'll just try to find that out. I think I'm missing. I'll just try to find out. And like if I want to, I see there is some project running on which I want to contribute. I will open that project, and you see this fork here, right? So I will pull it. So what will happen is that it will create the same whatever code is there. It would create. It would start reflecting under my drive. Okay, so if I go home, it would start reflecting here, right? Whatever, like I've said here, like this. If I fork this, it will start reflecting here. I can see all these repositories here, so I can also contribute. So using this, no, not this, using fork. I have to go inside this and then fork it. Okay, fine. I think we'll conclude today. Thank you everyone for today, and we'll discuss. We'll start tomorrow. Okay. I think some question. Yeah, it would be secure, obviously.
Yeah, one more thing. So, how much time we are having class? Like 3 hours or 4 hours? Like
2 hours. 2 hours.
2 hours, right? Okay, Saturday, Sunday, 2 hours.
Yeah, actually we exceeded a lot today, but yeah, just to give you something to consume today for today, right?
Okay. Yeah, yeah.
Some practical knowledge. Yeah. Okay, fine. Have a nice day. Bye bye.